So here is what to expect on the final exam for this class. I just decided to take a few minutes today to put on the paper the topics that are going to be on the final exam for this test, which is on the final exam for Math 353, which is ordinary linear differential equations. So please bear with me. You have the topics, not the questions. What you need to know to answer the questions. So the first thing is homogeneous equations. So it's called its final exam topic. The first topic is homogeneous equations. So these are equations of the kind f of xy dx plus g of xy dy equals 0 with f of x t g of y f of x t y t equals t to the power n f of x y and g of x t y t equals t to the power n g of x y for all x, y, t and the same n for both functions. So to answer such a question, you will not need on the final exam technically to know this definition, because the question will tell you, solve the following homogeneous equations. So what you will need to know will be the steps. And the step 1 is use y equals ux, then take derivative of y with respect to x, using the fact that this is a chain rule. So dy is equal to u dx plus x du. And then substitute in the equation. What equation? This equation. And next step, solve the obtained separable equation. Those separable equations will not be given as a separate question. Separable equations are present in the solution of the homogeneous equation. And the last step here will be to return u equals y over x and to the final answer. Of course, you need to remember that the solution has a constant of integration. C. Example. might have dx over dy equals x squared. Let me change this problem. Let's say x dx plus y minus 2x dy equals 0, for example. Then we say y equals ux. So dy equals u dx plus x du. Substitute that in the equation, get x dx plus ux minus 2x times x du plus u dx equals 0. And then in the next step, you solve the obtained separable equation. So you need to separate the variables here. So this is x dx, and then ux minus 2x times u dx. So that's going to be plus u x minus 2x times u, all of that dx, plus ux minus 2x times x du equals 0. And that is x times 1 plus u squared minus 2u dx. That's x squared u minus 2 du equals 0. And then we separate the variables and get dx over x equals minus u minus 2 over u minus 1 squared du. And this is equal to minus u minus 1 over u minus 1 squared du, which is minus 1 over u minus 1 plus 1 over u minus 1 squared, all of that times du. Therefore, solve the separable equation that we got, integrate both sides. You integrate here, you get natural log of cx in absolute value equals integral of this is negative natural log of absolute value of u minus 1. And then the other one is minus 1 over u minus 1. The constant of integration is already here in cx, so we don't need to use another one. So you get natural log of cx, absolute value of cx times u minus 1. If I bring this to this side, it becomes plus, and natural log becomes the natural log of the product. And I have that equal to negative 1 over u minus 1. And this gives us, last step, replace u by y over x. So this is natural log of absolute value of c times u times the x is y minus x equals negative, and then put u y over x. This is going to give you x over y minus x. That's it. And the problem is solved. The next topic is exact equations. For exact equations, you have an equation of the type m xy dx plus n of xy dy equals 0. It is useless here to remind what it means to be exact equation because the question would clearly tell you solve the following exact equation. So what you need to do is just to follow the steps. And let us do that on an example. So let's say we have x squared minus 2xy plus 1 dx plus 3 minus 2xy dy equal 0. I can make this here. We can change a bit. All right, that's more like it. And we have a problem like this, and I claim it's an exact equation and you need to solve it. What do you need to do? The steps are as follows. 1, integrate m with respect to x, f of xy equals integral of m of xy dx. That is integral x squared minus xy squared plus 1 dx, which is you integrate with respect to x, you get 1/3 x cubed minus 1/2 x squared y squared plus x, and then you have a constant of integration that is a function of y. Then on the next step, you take the derivative of what you got here with respect to y. So that's f with respect to y derivative equals, and that gives you minus x squared y plus h prime of y. And then you set it equal to n from your equation. That's n. This was m. So you set this equal to 3 minus x squared y. And then the next step, you solve that. You solve that for h prime. So you get h prime of y equals 3 minus x squared y minus, you send this to the right, that's minus x squared y. And things cancel here, you get that this derivative is equal to 3. So we get that h prime of y equals 3. It's always the case that this is never going to include x. If your answer at this point contains x, that means you have a mistake. Then you integrate this to find h of y. That's integral of h prime of y dy equal integral of 3 dy, which is 3y plus a constant. On the next step, what you do is take that h of y into the formula up there. So you get f of xy equals 1/3 x cubed minus 1/2 x squared y squared plus x plus 3y plus c equals 0. Set it equals 0 and you have it. That's it for the exact equation. So the next thing is linear equation. First order linear. And for first order linear equations, what you need to see is dy over dx plus p of xy equals f of x. That's what you need to see in the standard form. So whatever you get as problem, you make sure that you get that coefficient in front of dy over dx to be 1 before you start. And the steps in solving these problems are, the steps in solving this problem are, the first one is find the integrating factor. Find mu of x equals e to the integral of f of p of x dx. So let's say here we have our example. X dy over dx minus 3y equals x cubed. Let's see, that is the example. What I said in the beginning is to make sure that this coefficient is 1. So here, I need to divide by x first. So I'm going to get dy over dx minus 3 over x y equals x squared. So I divide both sides by x. When you do this, that's the p of x. And so that being the p of x, I'm going to get mu of x equals e to the integral of negative 3 over x dx, which is e to the negative 3 natural log of x. This is e to the natural log of x to the power minus 3, and that's x to the power minus 3. So my integrating factor is x to the minus 3 in this problem. Next step, multiply the equation by mu of x. In our example, that's going to be x to minus 3 dy over dx minus 3 x to minus 4 y equals x to minus 1, because I multiply x squared by x to minus 1. So when you do this, the next step is you write the left-hand side as d over dx of mu of x y and integrate. So that left-hand side is d over dx of x to minus 3y, and that's equal to x to the minus 1 or 1 over x. And you integrate this, you get x minus 3y equals integral of dx over x, and that's natural log of x plus a constant. And so you can solve for y. You get y equals multiplied by x cubed times natural log of x plus a constant. That's it. That's how you solve a linear problem.